All right, so we are now going to do part 2 of this lesson 7.1, angles in their measure. And you can see what today's goal is. We're going to learn the formula to help us find the area of a sector. We're also going to learn a formula to help us find the length of the arc that an angle would make on a circle. And then we'll conclude our lesson today with some other formulas that will help us find what is known as linear speed, finding the linear speed of an object traveling in a circular motion. So let's jump right in with a formula, and your problems 71 to 78 are going to involve these types of problems. What we're after here is, we talked yesterday how that an angle, we have this initial side and this terminal side. And those two sides, we use the term, it's a math term, subtends, kind of like it crosses over, and it creates on this circle something known as an arc. So I'm just going to shade in the arc that is created on the outside of the circle. And it's denoted here by the letter S. And if we want to know the length of that arc that's created, this shaded red area, this is our formula. It's the arc length is going to be found by taking the radius of the circle, and then we're going to multiply by theta, and theta is just another way of saying the angle measurement of this interior angle. Here's the key point. If you are in the habit of writing notes, this is a great place to write it. Theta, in order for this formula to work properly, must be in radians. So sometimes these problems can be tricky, and they give you this angle measurement in degrees, and it's a common mistake that people will plug that degree measurement in and use the formula, and that will give you the wrong answer. So make sure that if the theta measurement is not in radians, that you do that conversion before you use this formula. So if you need a calculator, now's a great time to grab it. You'll definitely want one. And let's take a look at some of these problems. So I just pulled out number 71 from this block of problems. We're told that the radius of the circle is 10 meters. Theta is given as 1/2 radian. So that's pretty easy. We just plug into our formula. S denotes the arc length. So the arc length is going to be 10 times 1/2, since theta is in radians. So the length of the arc is 5, and then you just have to pay attention to whatever the units of the radius, that will also be the units of the arc length. So this arc length is measured at 5 meters. Okay, 77 is an example, like I said earlier, where theta is given in degrees. So we learned yesterday how to take degrees and convert them into radians. So somebody tell me how I can take 30 degrees and change it to radians. Pi over 180 degrees. And when you do the simplifying, you end up with pi over 6. And so that's what we're going to use in our formula. So the arc length, S, will be found by doing the radius. Well, I got them switched, but that's okay because multiplication is commutative. We can do theta times 2. And let's see, since they tell us in the instructions to round to 3 decimal places, let's go to our calculator. And if we simplify this, it starts off as 2 pi over 6, which is pi over 3. So let's go ahead and plug that into our calculator and get the decimal equivalent. Pi divided by 3 and round it to 3 decimal places. And what is that number?
1.047.
And That's in inches. Okay, see how that works? All right, another formula that we use that's very helpful, instead of finding the arc length, which is what we just did, we are sometimes asked to find the area that is presented here in this red crosswork that I've done here on your slide. So the area of this, it's kind of like a pie shape. What would that area be? And here's the formula. And once again, theta has to be in radians, just like we talked about before. And so this is a pretty easy formula to use. It's just going to be your job to remember what the formula is. So let's find the area of this particular circle that has radius 10 meters. So it's going to be 1/2 10 squared. And theta is in radians. So once again, make sure that theta is given in radians, and it is in this case. And so we just use this simple little formula. 1/2 times 100 times 1/2, and looks like it's 25. So anytime you're dealing with area, it's always in units squared. And go off of whatever the units of the radius is. So this would be square meters. You'll be told 2 of these every time, and sometimes you'll have to. I think I have an example. Yeah, I've got some other examples where we're not told these exact 2, but we can solve for the missing one. But this is the formula that you're going to use anytime you're asked to find the area of the sector of a circle. The key point is, again, I'm going to say it again, make sure that theta is in radians. Common mistake people make. Okay. This time we're given that theta is 1/3 of radian, and the area is given, and we're supposed to find out what the radius is. So our formula is the same formula we used before. It's just that this time we don't know what r is. Okay. So we simplify this, and we get 1/6 r squared, and multiply by 6, and we get 12 is r squared. So to get r, we need to do the square root of 12, and I don't remember what they told us to round to. 3? Okay. So somebody have that? 3.464, and since the area was given in square feet, this radius must be in feet. Okay, we'll try one more. This time we're still trying to find area, but again, this time theta is given in degrees, so we need to convert it. And we did that once before. What's 30 degrees again in radians? Pi over 6. Okay. So r squared theta and simplify this. So I'll let you go to your calculator, and starts off as 4 pi over 12, which is just pi over 3. And 3 decimal places, what would that be? 0.46. 7. Okay. And this would be square inches. Area is always in units squared. Going back to yesterday's lesson where we took degrees and the conversion factor is to multiply by pi over 180 degrees. Okay, do you have any questions so far? Everybody good? All right, let's try this one where it's kind of utilizing both of those formulas. We have to find the arc length, that's the S, and then we are going to use that area formula. So what's the formula again to find the arc length? R times theta in radians, all right. And once again, where theta is given in degrees, so let's do the conversion. And we'll just go ahead and do it 3 decimal places. 70 pi divided by 180. 0.389. That look right?
Yeah, same here.
70 pi divided by 180. I hope that's what I said. 222. All right, so now we can do the radius, which is 12 times 1.222. What's that, Taylor? And that's yards. Didn't leave a whole lot of space. All right, now let's find the area. So what's the area formula again? Okay. And this time we're going to put 1.222 squared. I'm sorry, that's the theta. Back up. 12 squared. 1.222. So go to your calculator and plug it in. $87.984. And since that's area, that's going to be in square yards. Okay, questions? Questions so far? Okay, so we just have a couple more problems in your notes. We'll give you a couple more formulas involving the linear speed of an object that's traveling around a circle, and then this other formula known as angular speed. So pretty easy. Here is what you'll use, obviously, if you're trying to find linear speed. So an object is traveling around a circle with a radius of 5 centimeters. If in 20 seconds a central angle of 1/3 radian is swept out, what is the angular speed? Okay, so S is still the measurement of the arc. Okay, V is stands for velocity. T is time. All right. So another way of doing this, if you don't know if you're not told what S is, we'll have to go back to that formula that we learned earlier and figure it out. All right, which is the case in this particular problem. So what is R? Okay, and what is it? 5. And what is theta? And what is time? Okay, so in our calculator, 5/3, and I'm going to put parentheses around 5/3 divided by 20.
Yeah.
0.083. And this is in centimeters per second, right? Yep. Mm-hmm. The reason why I gave both of these is sometimes they go ahead and tell you the length of the arc, and you can just plug right in. That's what S stands for. But if you're not told the arc length, you're going to have to figure that out using this formula that we looked at previously. This is linear speed. We did the linear speed. Now let's do the angular speed. So that's what this little W, that's the Greek letter omega. That's what this stands for, angular speed. So it's theta, again in radians, divided by time. So pretty simple. So 1/3 divided by 20. 1/7. Okay, what do you think? Think you're ready? You can see another one? So with those formulas, it's really not a problem using the formulas. What the challenge usually becomes when you get your test, which formula do I use for which problem? So just make sure that you use the formulas purposefully and make sure you're connecting the right formula to the right problem, and I think you'll be good.